We'll go ahead and call the meeting to order and look at approving the minutes of the February 3rd, 2022 meeting.
I'll move to approve the minutes.
Do we have a second?
Second.
All in favor, signify by saying aye.
Aye.
It's approved. Do we have any unfinished business? Seeing none, we will move on to new business with part A of that being the IRC Chapter 11, and Sean is going to present.
Good morning. I'm Sean Redding, the Inspections Director. I'm sure you all know who I am. So today we're here to present on the IECC in Chapter 11 of the IRC. They've been completely rearranged to make it easier to determine which path to follow and find the requirements for that particular path. 95% of the residential contractors follow the prescriptive compliance path, but there are other options. As a result of this rearrangement, there are changes throughout the residential requirements that are organizational rather than substantial. The words perspective and mandatory have been removed from section titles throughout. Our intent is to adopt the code with amendments that bring the required R values and U factors in line with the Minnesota State Code. The Inspections Department has met with the local HBA, and as requested by this board, on some controversial topics. The specific topics are blower door testing, air exchanger requirements, the manuals J, D, and S, and energy certificates. We'd like to enforce the requirement currently in the code for the manual J and S. We don't feel a need to enforce the D at this point. And to be submitted when the HVAC permit is applied for, and the required energy certificates to be placed with the other required information to obtain a CO. When we will be implementing blower door testing on a random basis. We want to do this as this is as code allows, and the air exchangers are not required. A passive system is allowed by code, but when either option is installed, they must meet the code. So with the random blower door tests, we want to do it on, try and get it as fair as possible so we get a clear picture of what's actually going on. We've talked to some various people that conduct blower door tests in Moorhead, and after speaking to some of those people, when it was first implemented, a lot of the blower door tests were failing the first time. They weren't passing, so they go through, work with the contractor, make sure that they get things done, and they get a passing blower door test. But we want a clear picture of how things are really going, so when we implement these things, we're not on a random basis. We're going to do it during construction. We're going to allow the contractors to know at a point in construction where they can't bias it. So they can't go through and plug a bunch of holes or do this or do that. We're also going to be on site to witness them so that we have a clear picture of what deficiencies we may have. So that's the plan. We're not 100% sure how we're going to do the random tests, how we're going to do it to make it fair. It's been brought up just picking a random month and doing them all in that month. Anything that's going to be at the point we need it to be at to do a blower door test in that month, or take like a percentage, 5-10%, and just randomly choose them throughout the year. We're not 100% sure how we're going to do that yet. We have to work that out with staff a little bit more, but it's going to be, we're going to try and make it fair so that we're not picking on one person over another.
Sean, can you explain to us what the intent of the randomness is, what you're trying to accomplish or learn from that?
Well, what we're trying to accomplish is getting a clear picture from the lowest value house to the highest value house to see what we have out there. Because in the higher value homes, we don't have a lot of worry there about a blower door test, about what's going to happen, because we know that the money's being spent to make sure that those are tight. But that same tightness, that same aspect needs to be carried down to the lower houses too, the lower value houses, because it's an indoor air quality thing, and we need to make sure that we're enforcing the code across the board and that everybody's enjoying the same benefits from that code. So we don't want to pick on, well, we know this is a lower value house, we want to do a whole bunch of lower value houses because we know they're not going to pass, and we want to make sure that it's done right. We want to get a clear picture of everything that we have out there, from low end to high end, and make sure that things are being done right. And we're just trying to be fair about it and not pick on one person, so.
Is this gonna be something that you wanna do for a year or so to get, the info that you need
Yeah,
to know where
it's,
you're at, and not something that's necessarily
Yeah.
written in the code as a long-term process, or how are you looking at that?
well, the idea is to leave it in the code, even in the future, so we do have that option where if we see a home, somebody new comes in or something like that, we can say, we need to make sure that things are being done right, so we need a blower door test. So in the future, it may be misconstrued as picking on people type of thing, but when we have builders and stuff that know what they're doing, and we have them, they build in the area a lot, it's gonna be something that we can walk back a little bit and not do as much of, because we know what we're looking at, and they know what they need to do now. So keeping the randomness and also keeping the fairness in there, as well as doing it at a point in construction where we can witness it, and we can also, we're not telling every house you have to do it, so that in the beginning they're looking at it and going, well, we're going to take this house, we're going to make it nice and tight so that we don't have to do it on the next one. We want to get a clear picture of what they're actually doing, so we want to keep it kind of close to our chest for a little while and then let them know. And I know that might be a burden, but in the short term, it's going to help us get a clear picture. And in the long term, we probably won't do a lot of it after the first couple of years, because we'll know where we're at. The builders will be educated on where we need to be, and we can, look at things and say, yep, we know that this is going to be the same as the last one, so we're okay. We don't need to, we can count on the visual inspections a little bit more, rather than having to do blower door tests and cause more financial burden on those.
Have you, in the time that you've spent in the last month or two in the meetings with the HBA or whatever, what's your impression of the potential cost of solutions?
As far as if they don't pass the
Yeah,
blower
if they
door
don't
test.
pass it, is it an expensive thing to fix?
That's
typically?
where we want to catch it at a point in construction where it's not expensive, where it's easy to fix. We don't want to do it at the final, because then if you've got to rip out sheetrock, well, it's already taped, textured, painted, all that stuff. We don't want to do that. We want to do it at a point in construction where if they have to take a panel down, do something different, put it back up and make sure that it's correct, it'll be much easier and it'll lessen that financial burden. So we don't want to place an undue burden on anybody. We just want to make sure that we're getting a clear picture of what's going on. And, it's definitely not anything to try and get a contract or anything like that. It's more so just to make sure that we're doing things correctly.
Good, thank you.
With that, then Sean, are we gonna define that it's like pre-tape texture paint type of testing?
Yeah, that's the idea, is to try and get it before tape texture finish. We don't want the house finished. We don't want it at the CO point and then try and do a blower door test, because that's not going to do anybody any good. What we want to do is do it at a point in construction where they're tight enough. They basically have everything established within the house to finish it, but not, if they need to walk back a little bit of it and redo a couple of things, it's not that difficult.
Would you be planning on witnessing the blower door
Yes.
test, or would you just
Yep,
be looking for a certificate?
We want to have our inspectors on, and they've expressed an interest in being present for all those blower door tests. Now, we did have one blower door test that we did have conducted because there was no energy inspection conducted. They didn't call in for it. We did have one blower door test recently that was submitted to us because we needed something in our records showing that we were trying to do our due diligence with that particular property. And they came in very low, but they forgot to fill in a lot of information, and some of the information they filled in was not correct. So we had our inspector on site to witness it. Now, they did pass, but it substantially increased with our inspector on site. And that's what our fear is, that if we're not on site to witness it, they're going to kind of do what they want, give us the information and just say I passed. And we don't want that. We want an actual clear picture. We want to know what's going on, so when we're enforcing things, we're making sure we're getting it right.
Is there any kind of certification or signature required for the blower door test as far as the end of the form? Does it say anything about I'm certified to do these, or how does that work?
I don't know if there's a certification for it. I'm not 100% clear on that. I do know there are companies out there that do it, obviously, in Moorhead. But, we're just looking for basically a third party to come in and do the tests and give everybody a good picture. As far as the form, when we receive the form and stuff, we know it's going to be from a reputable person. At least we hope we are getting one from a reputable person, because they are in the area already. They already know what they're doing and they know how to conduct these tests. I don't know if they're licensed or certified or anything in the state of Minnesota or in the state of North Dakota. I'm not sure, but we anticipate that they're going to be using the same contractors they use in Minnesota, and we'll be getting the good contractors, the good people that know how to do these things. So when we receive the form and stuff, we'll be able to look at it and say, yes, this meets criteria. So one of the things that we saw on the form that we received this time was that the outdoor air temperature was 65 degrees that day, and we haven't had a 65 degree day. So that makes a big impact, you know. And they didn't have they didn't have airspeed on there. They didn't have wind speed rather on there. They didn't have a lot of information that we need. So when we do receive those, if they have the appropriate information and it looks appropriate for the time that they did it, especially since our inspector is going to be on site and they're going to be able to witness all the conditions that are going into it, we'll be able to hang our hat on it.
Is there anything like is the form that they fill out, is that something they get from the city?
No,
Or
it's going to be their own reporting information. It's going to be their own form that they're going to submit to us.
Okay, because I would like to see something that says at the bottom of it, I hereby certify that the information that's contained within the report is accurate.
And that may have been on that form. I didn't look that far down. There was another page that I didn't look at that was just informational pages. We were more concerned about the numbers at that point, and it was just the other day, so I haven't really looked at it real close again. But they may already have that on there, so we'll make sure that we're looking for those types of things to make sure it's a good, you know, that they're certifying that they did things correctly. And by having our inspector on site, I think that that's going to mitigate a lot of that.
Sure,
So.
okay.
If there's no other questions, I can continue on with the changes.
Does John have a comment?
I thought it might be appropriate right now. John Gunkelman, Dakota Construction. We've been working with the inspections department this has worked out. This has been a great session that we've been meeting with them over the last couple of months. And this was we were happy that we weren't going to do all the testing. If Sean can figure out with the department and I guess the attorneys how a random system might work, we're okay with that. I mean, it eliminates spending the money on every single house. The blower door tests will range probably somewhere between $300 to $400 for the tests. They do have Minnesota has we could probably get actually the form probably similar to what Moorhead uses. You know, Moorhead, we got their Jack before he retired. He gave us the information that their average, I don't know if they must have been tracking it, because he said their average blower door test was about 1.7 air exchanges. And I think one thing, Sean, you forgot to say that you did take the blower door test, I think, back from 5. Now it's up to 3. I mean, it's down to 3, you might say. And we're okay with that. I think it's tricky on the random, but I think from a builder's perspective, you know, we were just trying to figure out, okay, when you come to do the insulation inspection, would probably be somehow the thing, you know, we were joking, like when you're at the border and coming from Mexico, you hit the little red light to see if they're going to go through your suitcase or something. But the inspector brings a little box with them and you hit the button. Okay, you get the random test today. But that's got to be the time. You don't want to do it any later than that, because if there is something that has to be corrected at the insulation inspection, that's the time to do it. Otherwise, I think you're going to get people extremely upset that if you wait till the sheetrock's on even, Larry and I go back and forth about, you know, in a perfect world, you do multiple random, if a builder wanted to do, you do multiple blower door tests. But I mean, but I think if we can figure out the randomness of it, I think we're on board with that. You know, as a builder, I was joking, you might put an envelope on the bulletin board with $300-400 in it that, okay, I might get a random test. You're not gonna be able to throw it into your expense because you're
Right.
not gonna know if you're gonna get one or not. But I think if we can figure out how it will work, I think that the insulation inspection, when they do the insulation inspection, that's gotta be the time that it's determined whether you're gonna get the short straw or not, so.
Sure. Well, for me, I don't know what, the last meeting I was at, I heard that the blower door inspections cost $150 to $200. Now I heard $300 to $400. Is that?
300 to 400 is probably more at least, I mean,
Okay.
so,
Okay, I was just wondering if it had increased because of Putin or something like that.
No.
Everything else is his fault.
yeah, so, anyway, we're in sync with most of this, so.
Okay, thank you.
If there's-
During those conversations, I'm assuming that what we're trying to do here is use this as a learning tool. Both for the inspections department and the builders and subcontractors that are out there tightening these houses up. So that makes some sense. I don't know, and perhaps you'll get into that, but the remedies for the moisture conditions that get caused by the tightness. And I'm also going to want to hear about that today and how we're going to make sure that the smaller houses with a lot of people in it have the ability to deal with their moisture, because that's where the bigger problems are, and those are the less expensive houses with less expensive windows and all of that in there. So if we're going to tighten them up, like a plastic sack, we need to be dealing with that also. So
Yep.
I'll go on and continue.
And just to address that, because there's the passive system that goes directly into the ductwork of the house, that instance has been kind of addressed by the code. So if they're not doing the air exchanger, there is a passive system that they have to put in that's going to bring that outside air in and help regulate that moisture within the house and help regulate all that stuff. So there is provisions within the code to bring that outside air in and mitigate as much of that as possible. Now, if somebody's got 20 people living in a house, in a 4-bedroom, we don't know. We're not going to know that, and that's going to obviously have a significant impact. But all we can do is go with the houses as designed, as we see them after CO, after we look at them and say that, yep, if this was used in a standard way, it's correct. We can't go with those outliers like that. If we tried to regulate that, it would become a nightmare very quickly. So we're trying to regulate it. We're trying to take that into account, but there's going to be outliers that are just going to be outside our scope and that we're not going to be able to catch. It's just the reality of it. So.
Larry Mayer with Solution Design. I just wanted to comment about the moisture issue. An air-to-air exchanger can help with the moisture issue, but the source of the moisture is down below the slab. It's down by the footing. And so the passive radon system gives you a solution right at the source of the moisture versus an air-to-air exchanger, which can help, but it's not at the source of the moisture to get rid of, really dramatically drop that. So I would really encourage the passive radon being in every house, because you now can get to the moisture source and cut it down in going to building, all short of 100% capillary break at the foundation wall, which can either be at the top of the wall or at the bottom of the wall. But the moisture issue, the air-to-air exchanger is about a 20% effective Band-Aid for that. Really, the source is down below the slab, and that's where the passive radon can be much more effective. Thank you.
And just to let you know, that is something that the HBA did bring up with us in our talks, and I was going to talk about it. They would like to actually see that passive system put in because it does help. They've had some studies done in Minnesota where it's required, and it has, it's been a great thing for them over there. It's helped a lot.
What does it consist of?
Basically, they'd be putting some pipes under the slab, some perforated pipes underneath the slab, and then venting it out the roof, and it would just draw a lot of that moisture and a lot of that radon up and just dissipate it
There's no fan involved or anything?
There, in Minnesota, there's a requirement to put a outlet or at least run a wire up into the attic so that they could put a fan up there and help draw that out more, so it's no longer a passive system. But I don't know if we're gonna be able to require that, if we're gonna be able to push that very much, because that gets into the realm of the electrical code and things like that. And I know we can write something in there, but it's something that could be done later if need be. You can always grab a circuit for a small pump up there if you needed to somewhere else.
So this would require something like drain tile underneath the slab of for houses with basements and for houses without basements, just
Yeah.
underneath.
Yeah, it would be similar to that. I'm trying to get information from Moorhead about exactly what is required. We haven't been able to get that information as of today yet, but I keep asking. So we'll figure something out with it. I was going to bring it up and see if the board was interested in making that a requirement, because they have done studies and it has helped greatly. So.
You know, Sean, there already is a drain tile system on all of our houses that also works very well as a radon collector. So just sealing and venting that sump pit creates that passive system, and then just making sure that we've got the poly done well enough underneath the slab. I personally I've been doing passive radon for over 20 years. When I first heard that it was an issue, I didn't want to have one of my houses fail without a ability to fix it. So I would be in favor of having passive radon, especially with what we're trying to do on sealing them up. It's kind of the full package. It's part of why I personally wanted us to review this rather than just adapt what's in the book, because it is a system that needs to be complete or doesn't perform well.
So are you talking about just where, since you have drain tile around the entire perimeter of the house, you would just connect into the sump top, seal it up, connect it in, and have a pipe that goes
You
out?
can do it that way, or you can have a separate pipe that's in a wall that ties into that system also. But there's a few different ways to do it, but that's a real simple way that most of it's already there. And then we just put a power lead up in the attic, so if they ever do need to add a fan. But what we're seeing on a lot of closings is the houses are having to get an inspection, and if they fail radon, and you don't have that system in, you've got a lot of work to do. So with that becoming a norm in the real estate world, having the passive system in, and if it fails, being able to put a fan in is a pretty easy fix to get the house to pass. So
Yeah, and
So the ones that you have installed have the additional drain tile or the existing pipe, additional piping underneath, or you've just used the perimeter system that's already there?
I did both, and a lot of times to do the system that's underneath it, it's basically putting some drain tile down and a pipe coming up
So
through a wall
and you do it all, that would all be then separate from the sump pit?
from the sump pit. But the sump pits need to be sealed up anyway, otherwise you will have radon. You know, so it's harder to get to the sump, but you just have to figure out how to disconnect things. But that is one way of doing it. But I started doing it in all my houses when Minnesota passed a law a couple decades ago with that. So, John?
This is something in Minnesota that actually, we do a lot of work in Minnesota, and whether it's slab on grade, crawl space, basement, whatever, it's in the plumbers usually do it. We found it actually yesterday at our codes inspectors meeting. They actually said it's in their administrative rules portion of their code in Minnesota. But in Minnesota, all you have to do is put a 10-foot piece of pipe under the slab that's perforated, and then run I can't remember if it has to be a 4-inch. I think it can be a 3, all the way up to the roof. And believe it or not, I always thought that was sort of hokey until we had a meeting here about a month ago, and there have been very positive studies done in Minnesota. North Dakota, Minnesota, we're the capital for radon. And I think, as Clay made the point about closings for houses, radon testing now seems to come, you know, I remember 20 years ago, there was a big radon scare, and people like Western Products even had a radon division. I remember that back then. And back then, we were even figuring out ways to hook it up to the sumps and stuff. But this passive system has shown very good results in Minnesota. So when we were meeting about the air-to-air exchangers and the tightness of the house, those of us, of the builders that were there, you know, we said, we do this in Minnesota. Why don't we just incorporate this as another safeguard? It's an inexpensive way to do it. It's been very effective. And what Clay says, you know, the other thing in Fargo that we've been doing, houses built in the floodplain, you know, have to have a 10 mil poly vapor barrier and along with drain tile both inside and out. And so in Fargo, you as a builder, you have that option like Clay is talking about to hook it up to your sump pit. And if you don't want to do that, hooking it up to this passive system, I think we kind of, you know, part of the code is safety or is health and safety. I mean, and I think we thought that this was a great thing that we kind of volunteered. It's going to cost us a little bit of money, but we felt it was well spent with the houses getting tighter. And ironically, I've heard more about radon in the last 6 months on some home inspectors or home inspections that have been done. And so we think this is a good, inexpensive way to do it. I, as a builder, if I was doing this, I would do like Clay does, like in Minnesota. There's certain things that you just bring from one state to the other that you do. Putting the outlet up in the attic is not they kind of have a rule. It has to be 3 feet. You got to have 3 feet of headroom where you put it. It's not a bad idea at all in case you end up with a problem house. So anyway, we're totally on board with this. So
Yeah, I would just, along the lines of putting it up in the attic, there's, in the code, in the mechanical code, they go to great lengths to make sure things like, you know, flues don't go up in the attic and, you know, vent pipes from plumbing don't go up in the attic and stuff like that. So I guess the idea being is that the attic can at times transfer into the house, and the other thing would be, in this particular case, if it is below ground, there could be potentially moisture associated with it, which is, I think, one of the bigger things. When you have that moisture going up into a cold attic space and condensation and things like that. So I guess if we were to go and do something like this, my recommendation would be to,
I mean, it does go through the roof.
Terminate
Don't
it
get me
outside.
wrong.
Oh,
It's like a
I thought
sewer.
you meant
I'm sorry.
terminate
I'm
in
sorry.
the-
It's like a sewer vent. It goes right up through the roof.
Yeah, it does go.
Sorry,
all the way out.
I didn't explain that.
They just make a spot.
It's
for
not an
inline
electrician
fan.
putting a bath fan and dumping it into the attic. No. So,
Okay. Thanks.
Yeah, and with that, just for the rest of the panel to know if they don't, but you know, radon's one of the bigger causes of lung cancer and long-term exposure. So, and what you end up with is people have been in their house for 25 years and they end up with lung cancer, didn't smoke, didn't do anything, and the house tests high for radon. So that's why it became a health issue many years ago, was that issue. So.
Thank you.
Okay. If there's no other discussion on that, I can move on to the other changes within the code. Okay.
Sure.
Section 1101.7, pages 11-5 through 11-31, and IECC section 301, pages R3-1 through R3-36, deals with climate zones. The climate zone definitions and maps have been revamped. Approximately 10% of the counties in the country reclassified, including ours, which has moved from a 7 to a 6A. Section 1101.13.5, pages 11 through 40, IECC section 401.2.5, R401.2.5, pages R4-1. This new section adds a set of conditions to the compliance paths. One of these options must be selected in order to comply, or in order to use the compliance path. Section 1102.1, pages 11-41, IEC section R402.1. This section has been reorganized and expanded to clarify how R values shall be calculated with layered insulation in use. Table 1102.1.2, page 11-42, IEC table 4R402.12. The U factor requirement table has been switched with the R value minimum table. Staff recommends continuing the existing local amendment, altering the required U factors for our new climate zone, zone 6, to 0.057 for the wall frame column and 0.059 for the basement wall column. Staff additionally recommends adding a change to the ceiling column in zone 6 from 0.24 to 0.26. This amended table will continue to match the requirements of Minnesota. Table 1102.1.3 on page 11-43, or IECC table R402.1.3. Staff recommends altering the existing local amendment for our new climate zone, zone 6, to 0.32 for the fenestration U factor column, 49 for the ceiling R value column, 21 or 13 plus 5 continuous for the wood frame wall column, and 15 for the basement wall and crawl space columns. This will match the currently adopted Minnesota energy requirements.
The 0.32 for fenestration.
Mhm.
So that's altering the existing local amendment for our new code, 0.32. What is that 0.32 changed from?
Actually, I think the 0.32 has been included in the local amendment. I think the biggest change is that we'd be looking at the R15 in the basement instead of an R13. And that's just to match Minnesota code.
Okay. How hard is R15 in the basement to achieve without spending a lot more money?
Well, kind of depends upon how they're going about it. Now, I don't know if you're gonna want to require exterior foam like Minnesota does, and when Minnesota did that, I worked with the City of Moorhead's Codes Department to still have an interior foam condition, because exterior foam in this climate does not stand up very long, very well. The metal that covers it rusts out. In my opinion, it's just a warranty issue waiting for the builder to hear down the road. So we worked out a ability to spray foam and or do what we could to get 15 on the inside.
Yeah.
We currently do like a hybrid system where we foam out an inch and then use R13 for the rest, which gives us probably a R20 wall, but seals up the concrete, seals up the space between the floor and the concrete, so that helps with radon also. And then it's continuous up through the rim joist. There's probably some folks that are doing things that aren't to that level.
How thick do you have to go to get an R15 with your spray foam?
With spray foam, will give you about 7 per inch. So a 2-inch will get you to an R15. And what you need to do is keep an inch between the framing members and the concrete so that you get at least an inch of foam there to seal that up. But it then gets the foam outside of or inside and away from the metal outside or the different things that happen. And what I've seen with most of these foundations is you can't get them from foam to backfill to done without the foam being all beat up and either having to be redone or it's not being effective anyway. When you seal that inside with even that inch of foam, you now have created a really, really good seal, because most of these tests that you'll find in air leakage, a lot of it's happened at the seal plate.
Right.
So if it's foamed out, it's done. So there's some real positives for doing that. Well, we just kind of decide what our baseline is going to be and how we define that. And it took a while to get it through Minnesota to change it, but they did agree to it. for us.
My only concern would be isn't, you know, a 3.5-inch stud with bad insulation, if that's what you're gonna use, for instance, on the inside instead of the outside, is, what's that?
R13.
11, R11? for,
13, get to 13 now.
You get, right, so you get to 13 with 3.5-inch studs in your basement, but what I'm concerned about is if people don't wanna go to spray foam, which can be extremely expensive, or much more expensive than bat, now you're also forcing them to go to 15 and, you know, or 5.5-inch, or, you know, 2x6s, and that not only is more expensive, but it, you know, I mean, that's an extra, you know, 2 inches out of, you know, the square footage available in the house. I'm just wondering if the 15 at that point is really, going from 13 to 15 is really, how, you know, how significant that is when you maybe have one window that has more heat loss than the entire basement because it doesn't have windows, for instance. What are your, again, what we're talking about is the cost of that home. And, you know, we're talking about expensive homes and inexpensive homes. And I would think trying to go with a smaller home and put, you know, 2x6s all the way around the basement, if that's one of your options, or the foam, that's adding quite a bit to the cost of the home. And again, I'm not a general contractor or an architect, so I'm just a mechanical engineer that knows a lot about energy, but this is a cost issue, I would think. I don't know if it's significant or not. You guys deal with more general construction than I do, and I don't know how significant that would be.
You know,
So you can.
I like your thought where you're trying to match the product available to the code. So that does make some sense. I don't know what the other opinions are on that scenario, but
Honestly, we did kind of leave it intentionally vague for interpretation, for, you know, people to be able to figure it out themselves. There are installations out there that you can buy that aren't much more expensive than your standard bat insulation, that you can put it on a 2x4 wall and it achieves that R15, and it's just basically a bat. It's just a different material. So there is product on the market to address this and still keep a 2x4 wall. So I actually personally, we just bought here not too long ago, and we're looking at finishing our basement. And I was in Lowe's the other day, and they actually have on in stock bat insulation that can achieve an R15 for a 2x4 wall. So it's readily available out there, and homeowners can get it, contractors can get it. So it's there. It's not much more expensive according to what I've seen on the market. It's, you know, it's going to be a couple dollars more maybe per bundle or per bat or something. You know, it shouldn't be a substantial cost to the contractors.
Okay. Thank you.
Okay. Section 1102.2.12, page 11-45, excuse me, IEC section for R402.2.12. Heated garages have been added to the section for sunrooms, allowing thermally isolated conditioned spaces to enjoy lower R values than the main dwelling unit. The minimum insulation is an R24 for the ceiling and an R13 for the wall. Section 1102.4, page 11-46, IEC section R402.4. Staff recommends discontinuing the existing local amendment for R2 occupancies as selected, as section 401.5 already makes that distinction. It was added in 2009 edition of the code, but never removed.
question for you before we move on from the garages. Are you guys gonna require an R value on the garage doors? Being there in, you know, some cases, 35% of the exposed wall?
Yeah, if they're heated garages, yeah, we're gonna have to be looking at some type of insulated garage door or something that's gonna meet with
The
the
R13?
Yeah, some
Okay.
well, maybe not the R13. It might be different for the garage door, but you know, the walls and the ceiling are gonna enjoy a lower R value, which should help offset the cost of basement R values. So.
Well, kind of the standard entry door out there for garages is about an R7, R8. They do make them up to about an R17, R18. So you guys might want to look at that and see if that's, you want to set a minimum on that also.
You talking the overhead door?
the overhead doors.
I don't anticipate that we're gonna start looking at trying to make them put an R13 on the overhead door. We understand that it's an overhead door, it's gonna leak. We get it. You know, we're just looking to up the values when the garage is heated and stuff like that to make sure that the heat loss is mitigated. So if they're putting an R7 door in, I don't anticipate our inspectors going crazy and saying, no, you gotta change this out for a more expensive door. So.
Okay.
Section 1102.4.1.2, pages 11-46, and IEC section R402.4.1.2. This section includes a new exception for heated garages, whether attached or detached, that allows the visual inspection to confirm compliance. A second new exception was added for testing conditions in attached dwelling units and units smaller than 1,500 square feet. Section 1102.4.1.3, page 11-47, IEC section 402.4.1.3, staff recommends discontinuing the existing local amendment, removing the requirement for the air leakage testing. The new amendment to section 1102.4.1.2 still allows for visual inspection option for heated garages. Section 1102.4.6, page 11-48, IEC section 402.4.6. This new section outlines air sealing for outlet boxes to match those for recessed lighting already in the code. Either the air barrier must be installed behind the boxes or marked as an air sealed box, or a box marked as air sealed must be used. Section 1103.3.6, page 11-50, IECC section R403.3.6. Staff recommends adding a local amendment, striking item 3 and adding the exception to read, a total air leakage test shall not be required for ducts or air handlers that comply with sections 1103.3.2 item 1. Section 1103.3.7, page 11-50, IEC section 403.3.7. Staff recommends continuing the existing local amendment, allowing building cavities to be used as plenums. Section 1103.6.1, page 11-51, IECC section 403.6.3. Staff recommends adding a new local amendment, deleting this section requiring flow rate testing. Section 1104.2 and 1104.3, page 11-52, and IECC section 404.2 and 404.3 require occupant sensors, daylight sensors, or dimmers, or interior lights and daylight sensors for exterior lights. Staff recommends adding a local amendment, deleting these sections in their entirety. Sections 1105 and 1106, pages 11-53 through 11-61, IECC sections 405 to 406. These sections were extensively revised for clarity. Table 1105.4.2, number 1, page 11, and IECC table 405.4.2, number 1. Staff recommends discontinuing the existing local amendment to bring our requirements in line with those in Minnesota. Table 1106.5, page 11-59, IECC table 406.4. The energy rating index scores required for this compliance path have changed. Staff recommends adding a local amendment, changing the required value to the previous score of 58 from the new value of 54. Section 1108, pages 11-62, and IECC section 408. This is the new section referred to in section 1101.13.2. Houses following the prescriptive path must add one of these options to their design. Houses using the total performance path can either add one option or demonstrate that the design score 95 or less on the compliance report.
Could I have a question? On the previous one, table 1106.5, energy rating index scores required for this compliance path have changed. Staff recommends adding a local amendment, changing the required value to previous score of 58 from the new 54 rating. So in other words, this is a 58, I'm assuming, is harder to achieve than 54 as far as that goes. What was the reasoning behind increasing it? Was it just because that's what the state of Minnesota requires, or Where did we go from 54 to 58? What was
Yeah,
the reasoning?
we're just trying to keep consistent with what Minnesota's doing and also consistent with what we've been doing in the past. We're already making some other changes within the code and stuff, and we're trying to mitigate how many changes we make. So if we just keep with some of the same numbers and keep going with some of the same stuff for now, and possibly amending them in the future, I think it's easier on the builders and easier on the industry at this point. So.
Has there been any discussion sometimes when you get into these energy things and trying to get a score on the significance of 54 to 58?
No, I haven't had any discussions. I haven't had anybody bring it up. As far as we know, everything's being achieved at a 58 already. So
Okay,
if we can keep it, we can keep. We'd like to keep it.
okay, thank you.
Okay. And sections 1109 11, yeah, 1109 to 1113, pages 1162 through 1164, are chapter 5 in the IECC, pages R5-1 through R5-3. These cover existing buildings, alterations, additions, and historic buildings. There were no significant changes outside of renumbering the sections and rewording them to match the newly organized code. And with that, that's the last change I have for the residential.
Anybody have any questions for Sean? Thank you.
Okay, thank you.
Thank you.
We will move on to the IECC presented by James Showalter.
Good morning, James Showalter. I'll be presenting the commercial chapters of the 2021 IECC. Starting on page C1-1, we would like to propose a new amendment to identify the city of Fargo as the jurisdiction named in this code. It just simply replaces the name of jurisdiction line with city of Fargo. Then on chapter 2, page C2-1, in definitions, the definitions of biogas and biomass have been added. And then on C2-3, the definitions of fan efficiencies have been added, including the new term fan energy index, which replaces the term fan energy grade metric, which aligns the IECC with ASHRAE 90.1. Chapter 3, page C3-35. There's a new climate zone 0 that includes about 10% of the country, and Cass County is now in climate zone 6A, formerly 7. Chapter 4, page C4-1. Compliance path options for commercial buildings have been outlined, and the sections that each path must follow have been listed: prescriptive, total building performance, or ASHRAE 90.1. Page C4-1, the thermal envelope certificate is now required. Page C4-3, table C402.1.3, the R values in this table have increased to be closer to ASHRAE, as well as increase the efficiency of the building. Page C4-4, table C402.1.4. The U factors in this table have decreased to be closer to ASHRAE, as well as increase the efficiency of the building. Page C4-9, table C402.4. The U factor and solar heat gain coefficient have been decreased to increase the energy efficiency and align closer with ASHRAE 90.1. Also, the orientation has been removed from the table. C410, C402.5, air leakage thermal envelope. There are new requirements for dwelling units in R and I occupancies, revised requirements for other than R and I occupancies, and new performance verification requirements. Got a little typo there. C4-13, operable openings, interlocking. With exceptions, openings larger than 40 square feet now must be tied into the HVAC system to limit heating to 55 degrees and cooling to 90 degrees. This change can occur within 10 minutes of opening the operable opening. Let's see. C403, page C4-37, C403.4.2.3, automatic start and stop. Automatic stop controls are now required on systems with direct digital controls serving an individual zone. On page C4-48, C403.8.3, fan efficiency. As mentioned earlier, the fan efficiency matrix has been replaced with the fan efficiency index, and this section has been rewritten to reflect that. Page C4-48, section C403.8.5, low capacity ventilation fans. This is a new section that covers efficacy requirements for ventilation fans with less than a 12th horsepower motor. This has been added to allow these smaller fans in mid-rise multifamily buildings and smaller commercial buildings. Page C4-60, C405.2.1.2, occupant sensor controls in warehouse storage. This section was rewritten to clarify how occupancy sensors are to be configured for warehouses where previously there was confusion. Page C4-66, parking garage lighting control. This is a new provision that states that parking garages must have either occupant sensors or time switch controls in accordance with the provisions of this section. And that was section C405.2.8. Page C4-70, section C405.4, lighting for plant growth. Now 95% of plant lighting luminaries must have specific minimum efficiency. Page C4-72, section C405.11, automatic receptacle control. This is a new section that now requires 50% of receptacles covered under this section and 25% of branch circuit feeders to have an automatic receptacle control.
We're talking about outlets?
Let's take a look here. It's been a while since I did this review because we took such a long break. I'll just look at it real quick. 405. Yeah, yep.
So that means that 50% of outlets now need to have some kind of automatic control where there's not power to them at based on some kind of a timer or automatic control system?
Yeah, let's see, it's, the change significance in the significant changes says the inclusion of provisions for controlled receptacles brings practices common outside of North America and required in California and in ASHRAE 90.1 into the IECC. So 50% of covered receptacles and 25% of the branch circuit feeders to be automatically controlled receptacles. Methods for meeting these requirements include using split wired receptacles that provide at least one controlled outlet, or two for any uncontrolled outlets, ensuring that at least one controlled outlet is located within 12 inches of the uncontrolled outlet. And to avoid the unintentional loss of power to equipment and appliances, it is critical to note both the requirement, all controlled receptacles be permanently marked in accordance with NFPA 70 and the application exceptions. And these provisions are applicable to both the IECC compliance paths.
It seems like a ridiculous requirement to me. I see no reason for it. I don't see energy savings. I don't see anything where you have lights or computers plugged in the wrong outlet. Now you have to go through and mark every outlet that says this is controlled and might shut off automatically. And now you might have to, I think, maybe run a whole separate wiring to, you have a double outlet and one of them's automatically shuts off and one of them doesn't. I think this is a ridiculous requirement. To be honest with you, I would eliminate it.
I think most of the commercial buildings are using a COM check to show overall compliance. So I believe that might as long as that's taken into consideration, I think, they can make up for it in other areas.
Okay.
All right, page C4-75, section C405.12, energy monitoring. This is a new section requiring energy monitoring systems be installed in new buildings over 25,000 square feet, with an exception for individual units under 5,000 square feet in an R2. Page C4-76, section C406.1, additional efficiency requirements. When using the prescriptive compliance method, designers now have the option to gain credit or points from a series of new tables that assign points based on use group and climate zone. There's a list of 11 building elements that can be awarded these credits or points.
I'd like to go back to that energy monitoring. 25,000 square foot building. What exactly is energy monitoring? I mean, I've done energy monitoring where we know how much electricity is being used and gas is being used, and there's a dashboard and all that stuff through, lead projects. But what exactly is the impact of, what is being monitored, I guess is my question.
This says that energy monitoring provides a means to measure and retain the energy performance of a building. Although the IECC requires mechanical system and service water system commissioning, without a monitoring system in place, building owners and operators often do not know if energy efficiency measures have degraded, gone out of calibration, or are experiencing some other issue that is reducing the return of investment and increasing the payback period.
Yeah, my thought is that owners that own buildings that are 25,000 square foot typically aren't going to monitor that necessarily, and then the cost of what exactly you're monitoring, other than the electric meter and the gas meter instantaneously, which you would find in your electric and gas bills at the end of the month, to monitor them on a daily or hourly basis on a 25,000 square foot building. To me, and again, I don't know, you guys designed 25,000 square foot, 50,000, 100. I mean, what is your thought on the amount of cost it would, to monitor I just don't know what throwing a monitor on the electrical meter and the gas meter so you can read it directly. First of all, those two monitors are not inexpensive. And who's going to look at it?
Yeah, I think it talks about automatically sending it, so I don't know if they get
To
a
who?
port. Yeah.
The janitor?
Right.
25,000 square foot buildings don't have, people that monitor building automation systems. 50,000, we get up there where we start to have building automation systems, certainly 100,000 square foot. 25,000 just seems like a very, very small amount of square footage to force an owner to monitor their energy on a hourly or minute by minute basis, or have that ability. I guess my recommendation would be to push that number up from 25 to perhaps 50. You just don't have building automation systems in 25,000 square foot buildings very often, and this is even in the buildings where we've installed a lot of energy or building automation systems. I mean, this wouldn't be that big of a deal to add to it, but you do have to have a meter. For instance, gas, now you have to have, I think, another separate meter. I'm not sure if you can tie into the gas. The gas company won't let you tie into their meter, I don't think. I think you have to have a whole separate meter. And those are thousands of dollars. They're not, $100 items. And then you have the you have the wiring associated with them, which isn't a big deal, but now you have to actually have a software on your computer to monitor that. And again, on 25,000 square foot buildings, you're lucky if you have a janitor that's there every day. Typically, it's just a cleaning crew, and they come in, but the people that are in those buildings don't typically look at them. I guess I would recommend that we, change that to 50,000 square foot. I don't know what the rest of the board how they'd feel about that, but I just think 25,000 is such a small square footage to be monitoring.
Yeah, the level of sophistication of most building owners that are that size, you wouldn't have anybody that would be monitoring it on a daily basis. I wouldn't think.
I mean, that's a.
You already have means that are there for you to analyze on a monthly basis your energy consumption. So what good is knowing what an hourly or day-to-day basis, what good is that going to do for a building owner? And at what cost? It might be that what they're saying here doesn't rise to the level of having to add additional systems beyond just a standard control system or a standard, the energy consumption on the power side is maybe a little bit easier to monitor, because you could have a separate meter. But I agree on it. If you're trying to monitor gas, or if you're trying to monitor other energy use components,
Think of
it gets a
fuel,
little-
if you had fuel, or propane. Now you've got a whole separate metering type of a thing that has an electrical or an electronic connection to it. It has to go into some kind of a, computer monitoring system that you would buy. I don't necessarily see the upside of this on those sizes of buildings necessarily. I mean, if people, because it's not in the code, doesn't mean that people that are concerned about that kind of thing can't put it in. But I just think that 25,000 square feet is a pretty, my experience, 25,000 square foot is a relatively small building.
Sure.
I don't know if we could have you review that and
Yeah, we'll definitely
consider, a higher square footage before
Absolutely.
it would be implemented.
Yeah, we can look at the last two that you mentioned with the controlled outlets and the size of the metering buildings.
Thanks, James.
Yep, all right. Any other comments on that? Okay. Let's see. Page C4-84, C407.2, performance-based compliance. The terms mandatory and prescriptive have been removed from the section titles to avoid confusion. A new table has been added to reflect the requirements when using total building performance method. And then just one last note from the residential sections, we'd like to propose a new amendment to add the city of Fargo as the jurisdiction named in this code. And that's all I have. Any questions?
What does that do to us as far as approving these, to make changes, say from 25 to 50,000, which is just obviously a random number? What does that do for us? Or how do we get around that and approve these meeting minutes?
So if I'm right, the question you're asking is, can we make the change from 25 to 50,000? All it'll be is when we send the information, since this board is recommending it, we'll send the information to the lawyers when they're drafting the ordinance, and we'll make that distinction, we'll make that change, and then present it to the city commission. And if they want to accept the change, they can. If not, they can make recommendations on that as well, and then we'd have to go back and redo it, basically. Okay. So if this board wants to make changes, wants to make recommendations to delete sections, change sections, things like that, that's why we bring it to you, so you can make those decisions and direct staff on what we should be pushing up the ladder, basically. Thank you.
Can I make a suggestion on the energy monitoring? Would it make sense to reach out to a couple of engineers and just say, well, what is the approximate cost on a 25,000 square foot building? And I mean, we could come up with just a hypothetical building, it's 25,000 square foot commercial building with tenant spaces, or, 2 tenants or whatever. Well, and just say, what is the additional cost for systems? And I'm just reading through the metering requirement, the data acquisition systems requirement, the graphical energy report requirement. Mm-hmm. There's a lot going on there. Yeah. And I agree. I think it's, for somebody that's interested in diving into their energy consumption on their building to that level, it's probably a great thing. But the vast majority of small business or small building owners or small developers that have buildings of that size aren't going to have the sophistication to handle all of that data that's streaming their way. I mean, it says that it has to be able to report at least hourly, daily, monthly, and yearly for the previous 36 months. Mm-hmm. That's a fairly major burden to carry for a builder or developer on that building of that size. Now, if this is an institutional building and it's at one of our school districts, or if it's at one of the universities, it's a totally different thing, I think. But in most cases on small commercial buildings, it seems like it's a reach.
Yeah, and I guess the thing that comes to my mind is on a lot of, let's say 25,000 square foot, just a warehouse or a contractor's, for instance, where mostly you've got a big, huge empty space and maybe a couple of offices and a furnace, something like that. I don't get, the kind of sophistication that you would need in that kind of a monitoring. And then the other thing is there are a lot of mechanical contractors that design and throw this kind of, put mechanical systems in unsophisticated buildings. Sometimes you need a mechanical engineer at a certain sophistication level, and sometimes you don't. And again, now they would have to install and understand all that energy monitoring stuff, and I just don't know if that's in their wheelhouse. So yeah, I would, and again, it's more complicated than just saying energy monitoring. That's an easy thing to say, but we've had to do it. We did a dashboard for the Gurecki Center or the UND Alumni Center, and it was extremely complicated to get it to all work together so you could understand it. And we had extremely smart people working on it. So I just think 25,000 is just a little bit.
Well, and reading through this chapter or the section and stuff like that, it seems to be to me, it seems the intent is to gear it more towards the higher energy consumption type of buildings. So if you've got a 25,000 square foot factory facility and they're going to be consuming a lot of energy, they want to be able to, they should be able to monitor it and things like that. To me, it does leave a lot of questions though, and it does leave a lot of burden out there and not a lot of clarity. If we want to try and up it to 25,000, I think there's more work to do throughout the whole section. It may be more advisable right now to delete the section and just allow people who want to monitor their things to monitor their things, because people are starting to do that anyway.
Right.
And it might become a moot point in the future where everybody's doing it anyway. We don't have to worry about it. But I do agree that the, say like a small office building, a 25,000 square foot office building, what are you going to monitor? Computers. We already know how much they consume. You're already going to be able to basically monitor that through your utility bills and things like that. And you're going to try and make those cost savings anyway. We've seen it in retrofits for lighting. We've seen it in retrofits for many other things, just trying to consume less to lessen that burden of that utility bill anyway. So I think, to me, there's a lot of questions in this section, and it's not real clear on what they're trying to achieve with it. At a 25,000 square foot building, that leaves a lot of buildings out there that would need this, but may not potentially use it for anything, or may not be able to use it to save any costs or anything like that. So my recommendation would be to delete it in its entirety and not try and alter it, because it's going to get very, very involved.
No matter what level you pick, no matter what size you pick, it's going to seem kind of arbitrary. And so it seems kind of arbitrary that they put 25,000 in here to me. So, what if your building is 24,000? Is there not enough benefit to recommend doing it there? I think I would agree. I think that eliminating it and leaving it up to the individual building owner to decide whether they would choose to have a higher level of monitoring than they're already getting from their utility company would be
And
my recommendation too.
I have seen large facilities, for instance, Cloverdale and Mandan, and they do have monitoring systems in place for certain things. So they do watch their own things because it's information that's valuable to them at that point. This information might not be valuable to a lot of people, and it might just be an added cost. So
That may be more industry specific, if you've got a really big plant and you want to try to use it as a training device for your employees and to try to conserve energy. And it may tell you if someone's got an overhead door open for too long of a time in the winter, but do we need a system to do that?
Yeah.
Well, the one that we did at the Alumni Center up in Grand Forks, which was solar panels and heat pumps and all sorts of stuff. That was a thing, so they could show that they were, using. You can pull it up on the internet, and you can go to their energy use and see what their electricity is doing, how much input their solar panels are doing. But it was a very expensive system. Just to get it tied into the internet cost $25,000, and that was 6 or 7 years ago. So
Yeah, and
I would agree with what your recommendation would be. Is we, for now, this could be, this could be taken out, and in the future, if it's deemed as perhaps becomes more commonplace, more owners are doing it to watch their energy usage, we could maybe adopt it at that point. But I would say I agree with your recommendation to perhaps scrap it because of the complexities of doing just small things in it.
Sean, would you like a motion for that?
I would like a motion on those two, just that, so we have it clear on the record that this is the direction that the board wants to go. So this one and the receptacle control, 40511, and then this one. I'd like motions made on those if you wouldn't mind, and a vote.
Okay.
I'll make a motion to eliminate the receptacle control that's been discussed, and the energy monitoring that's been discussed at the meeting.
Okay, we have a motion to
I'll second.
eliminate C 405.11 automatic receptacle control and C 405.12 energy monitoring. Do we have a second on that?
Second.
All in favor, signify by saying aye.
Aye.
Motion carries.
Okay, thank you. I think that's all we have for you guys.
I have one other question for you, and this may be something that we want to put a motion on too, but with the passive radon system, do you need some direction on that also too? If we're going to include that, or is it,
Yeah, I would like some direction if you guys would like to include that as a local amendment to, put that into the code. Yes, I would like a motion to find a place for it.
Before we would do that, what I would have a question of is, I've heard that, and I don't remember who it was that mentioned it, but just even, putting a 10-foot pipe underneath the actual floor of the building instead of using the drain tile around it. We've done this over, in different buildings. We've put actual drain tile every 25 feet, with really no guidance as far as, well, what is the best way to do it? And if you do anything, it's kind of approved. Well, did you do something? Yeah, we put in a 10-foot pipe. So the question would be, that I would have, is if we were to do that, how would you guys as codes inspect that, or what would the requirements of it be?
Since we have studies and we have information from Minnesota already, it would be preferable to use their rules, the guidance that they've already provided. It's an appendix that they do adopt and we don't, but they do have specific guidelines for it as I understand it. So if we would just copy that, basically, copy and paste it in ours and just find a good spot for it. It's something we've been kind of looking at, but I don't think we found a great spot for it yet. It's been suggested that we could put it in foundations because it's being done at the same time, things like that. So we can try and copy and paste basically what Minnesota is doing and just keep consistent across the two communities. If that's the direction you'd like to go.
I think that would be, having it be the same code for both Minnesota and North Dakota, so that our contractors perform the same system, is probably the best way to do it, so that it's not difficult for them to know what to do. So, any thoughts? Okay. I would like to see a motion to include passive radon, if anybody on the board would like to make that.
Should we, is that something maybe we should table until we see? I'm not familiar, and I don't live in the residential design or construction world, so I guess I'm not familiar with that, the particular appendix that you were speaking towards. Is that something we should table and review?
We
later
can
date?
table and review it, but that's going to push our code adoption back because we have to wait for this component before we can do code adoption, and we'd like to adopt as quickly as possible. From what I understand, the way they do it in Minnesota is you run a 10-foot length of corrugated pipe, or not corrugated, perforated pipe underneath the slab. It may involve teeing out in some instances, depending on how the configuration of the building is, and then just running either 3 or 4 inch pipe that goes up and vents out of the roof. And that's the only requirement, that's all they do.
So do we, and I would lean on Clay, you for your expertise here in the residential world, but are you running interior drain tile with exterior drain tile and tying those together in some way, shape, or form? And then that, I think, ties into the pipe that goes out through the roof and vents the gas in the passive fashion.
The reason I suggest that is that system already exists as far as the drain tile system, so that's there if you want to just tap onto that. The other system that's defined in that is an alternative. A lot of people do that also. So I think the code probably already has it in there if we just adopt the same rules that are being enforced in Moorhead and on the Minnesota side, that they can pick whichever one works for them.
My only, the thought that goes through my head on that and is Mike's exterior and interior. I just wonder if there's ever been any tests on, if you do it outside the foundation, if the radon is coming up below the building, you know, through the, it's basically, this radon is something that's in the ground, right? So if all you have is drain tile on the outside of the building, and you pop a vent out of the top of your sealed sump pump lid, does that actually eliminate the radon that would be seeping in through cracks in your slab underneath your building? That would be my
The
question.
drain
That's
tile
where the
systems,
4 inch.
you have to have interior drain tile throughout a residential structure. So that's,
That's required now?
I think the only caveat to that is there are some residential structures that don't require drain tile. So we
yeah, if
wouldn't
you're
have
slab
that
on
system.
grade.
Yeah,
Yeah.
so we wouldn't have that system in place already. So having this add-on system or this additional system ensures that all houses end up with it.
What I would recommend is either an interior drain tile system then would be something that you could connect onto the sump pump system, but the cover would obviously have to be sealed, which is not necessarily always done well, or a 10-foot length of pipe or whatever the state of Minnesota kind of says is an alternative. So if they've already got that all,
Yeah, and it's an appendix within the code that we just haven't done. So it's already there. It's just that we never adopted it.
Yeah.
So basically just adopt that appendix in the code. It'll be what the local contractors have been doing on the Minnesota side here. So nothing new to them, and a proven system. So we're not reinventing the wheel at all with that.
yeah, I don't want to add something that's, thousands and thousands of dollars
No,
throwing in a
it's-
simple piece
It's
of
really inexpensive. It's
I
tape and.
think at one point somebody said it was like $150, $200 at most.
Okay.
So it's not very expensive and it's not very
Basically
time
some-
consuming.
Does this, I absolutely agree with it. Is there stipulations then that still regulate what happens from that interior sump pit or pits, that you have to have any sort of particular seal on it or any vent or any color coding on that pipe if and when radon appears? Is there a need within that for the additional outlet in the attic space? Is this an all-inclusive?
the passive radon requirement does require that it gets vented to the roof.
Okay.
So they have to use a 3-inch PVC from whether they do the pipe in the ground or tie onto a drain tile system, and that does need to be vented out to the roof. They put a power source by it in the attic, so if you want to add a fan or need to add a fan, it's there, so you're not.
And that's all stipulated in that appendix, so everybody follows the same rules, so, if yourself or Gunkelman are building something, you guys follow the same protocols, and then that would just translate into North Dakota is basically what we're working
And the
towards.
main reason I'm looking at it is for what we're doing with making sure that we're getting the homes tighter and tighter and really sealing that up. That also traps anything that's produced within that home. So trying to relieve the bad things while you're having a fresh air system is vital to making that whole thing work. Otherwise, you're only going halfway there.
Right. And I apologize if I'm acting like I don't know what I'm talking about. I actually put it in my house, so it's a awesome scenario, and it was not expensive whatsoever. I just want to make sure that these are, I don't know if there's stipulations within that you know about since you kind of work in that or
Yep.
live in that industry. So
I'd support adding a passive radon system, ventilation system. We've put similar systems in buildings where there's been environmental issues, gases and other things like that. And for pretty sizable buildings, it's not been a very expensive system to put in. Be very economical, and whether you tie it to the sump pit or not, or do some of the things you're talking about, drain tile and things, that would be sort of a moot point if we just did the passive system, and then you're going over and above and beyond if you connect the drain tile and sump system or add that to provide extra protection.
So did we make a motion? Was
We
there
would need a motion to adopt the appendix for passive radon that's within the code.
I would make that motion to adopt Minnesota appendix relating to the passive radon, under slab and piping through roof
Ventilation.
ventilation design.
I'd second that.
All in favor?
Aye.
Motion carries.
Thank you, guys.
Thank you.
We're done, I guess. If you have any other questions.
Any other staff reports? Everybody's good? With that, I'll call for adjournment. All in favor?
Aye.
Thank you.